Hi, in this video we are going to learn how to calculate the probability of inheriting a specific genotype. But before we could do an example problem, we need to learn when we should multiply and when we should add. So we're going to multiply when we're looking for the probability of two or more independent events occurring at the same time. So an example could be, what's the probability of gene A having this genotype and gene B having that genotype? And the key here is that when we say and, we're going to multiply the probabilities. And we're going to add when we're looking for the probability of two or more mutually exclusive events occurring. That means those events cannot occur at the same time. So an example could be having this genotype or that genotype. And that means that you can't be homozygous dominant or heterozygous dominant or recessive all at the same time. You could only have one of those genotypes. So the practice problem is you cross a pea plant with the genotype big A, big B, big C, big D with a pea plant that is big A, big B, big C, little d. And we're looking for the probability of the offspring having the genotype big A, B underscore, C underscore, little d. The underscore and B underscore and the C underscore is implying that we're looking for either a homozygous dominant or a heterozygous dominant. And to calculate the genotype of the offspring, we're not going to do all the alleles at once. We're just going to focus on one gene at a time. So we're going to start off with gene A. So we're looking for the probability of the offspring inheriting big A, and little a. So that means we're going to be multiplying. So from parent 1, there's a 50% chance of inheriting little a because out of the two alleles for gene A, only one is little a. So that's how we got the 50%. And for parent 2, there's a 100% chance of inheriting big A because out of the two alleles for gene A, both of them are big A. And then we're going to multiply the probabilities to get 0.5. For gene B, we have the underscore, meaning that we can be either heterozygous dominant or homozygous dominant. So we could be big B, or big B, or little b, big B. And the difference between these two genotypes is that in this genotype, the big B comes from parent 1 and the little b comes from parent 2. And in this one, the little b, comes from parent 1 and the big B comes from parent 2. So to calculate the probability of big B, from parent 1, there's a 50% chance because out of the two alleles for gene B, only one is big B. And this is similar for parent 2 with only one of the alleles being big B out of the two alleles for gene B. So we're going to multiply 0.5 times 0.5 to get 0.25. And for big B, little b, there's one big B from parent 1 and one little b out of the two alleles from parent 2. So 0.5 times 0.5 once again to get 0.25. And this is similar for little b, big B, with parent 1 having one little b out of the two and parent 2 having one big B out of the two alleles for gene B to get 0.25. And since we said we can't have all these genotypes at the same time, we're going to be adding them because you could have big B, big B, or big B, or little b, big B. And that gives us the total probability for gene B being a dominant phenotype as 0.75. And then for gene C, we yet again we have an underscore, which implies that it could either be big C, or big C, little c. And this time there's only one genotype for the heterozygous dominant genotype because parent 2 only has big C. So to calculate the probability of big C, We know from parent 1 there's a 50% chance of inheriting big C because of the 2 alleles, only 1 is big C, and for parent 2, both of the alleles are big C, giving us a 100% chance, and when we multiply we get 0.5, and then for the probability of big C, little c, only parent 1 has 1 little c out of the 2 C alleles, possible C alleles, and parent 2 has a 100% chance of donating a big C. And we're multiplying those to get 0.5. And then we're going to be adding up these probabilities to get a total of 1. And then we're looking for the probability of little d. And from parent 1, there is a 0.5 chance of inheriting little d. And from parent 2, there's a 100% chance of inheriting little d since both the alleles are little d. And that gives us, after multiplying those probabilities, 0.5. And finally, since we're looking to have these specific genotypes for gene A and gene B and gene C and gene D, we're going to multiply all the probabilities that we got earlier to get a total probability for this genotype as 0.1875.